In this video, I'm going to look at the extraction of aluminium. So the first thing to say is aluminium is actually a very common or abundant substance, abundant element. The only problem is because it's so reactive, it actually occurs combined with other chemicals in substances that we call ores. So the main ore of aluminium is called bauxite. So just think of the ore as a rock, and within this rock, this ore, we've got the chemical aluminium oxide, and there'll be other stuff as well. So essentially what we need to do is to get the aluminium on its own. The first step of this process is to get rid of all the stuff that we don't want, this other stuff in the ore. So the bauxite is purified and we end up with a white powder, which is actually the chemical aluminium oxide, Al2O3. The next part of the process is electrolysis, and electrolysis of aluminium oxide would give you the aluminium metal. So what I'm going to do now is focus on this part of the process, the electrolysis of this aluminium oxide. So to be able to pass electricity through a substance like aluminium oxide, which is ionic, we've got to get those ions free to move. Now one way to do that is to melt it, so turn the solid into a liquid. Now the problem they've got is the melting point of aluminium oxide is around 2000 degrees Celsius. So they're going to spend a lot of money and they're going to use a lot of energy to make that process happen. So you can see instead of doing that, they dissolve it in a substance known as cryolite, and that needs to be molten. And all the cryolite is a less common ore of aluminium. So what they would end up with is a mixture of molten cryolite and molten aluminium oxides, and these are mixed together. Now we said before that takes about 2000 degrees Celsius to melt the aluminium oxide. When you dissolve it in the molten cryolite, we're talking about 900 degrees C. So straight away you can see a big advantage there. That's going to be cheaper, it's going to use less energy, and so that's got to be better. So now we've got the aluminium oxide in a liquid form, we can pass electricity through it and release the aluminium from the oxygen, and that's done by electrolysis. So we'll have a look at that now. So the electrolysis cell looks something like this. So I'll just go through the diagram. We've got this green line here represents the outside casing of the cell, and then you can see there's an inner black line there. There's a deliberate gap there, black line there. We'll just see where that goes. So this is the negative electrode, and this is made from carbon. So negative electrode is what we call a cathode. Carbon's used because it's a good conductor of electricity. And then we've got these rods dipping into the tank, and these are also made of carbon, and these are the positive electrodes, so these are the anodes. So what have we got inside here? We've got that mixture of aluminium oxide which has been dissolved in molten cryolite. So this is sort of essentially a liquid in here. So which ions are in here? We've got aluminium ions and oxide ions. So aluminium ions have the formula Al3+, and oxide ions have the formula O2-. So what's going to happen? Remember, opposite charges attract, and so the positive aluminium ions are going to be attracted to this negative electrode, that's the lining here, look, and then the oxide ions are going to be attracted to these positive electrodes. I'll just put a few in there. and so we've managed to separate the aluminium from the oxygen. So what we need to do now is have a look at what happens at each electrode. So we'll start with the process that's going to take place at these anodes here. So the negative oxide ions are attracted to the anodes, and what's going to happen is this 2- charge, which is being brought about by having 2 extra electrons, it's going to get rid of those 2 electrons, and the oxide ion becomes an oxygen atom. Now if 2 of those ions do that, then each one loses 2 electrons, so 2 would lose 4, and you'd end up with 2 of these, and so we form the O2 molecule. And so you can see I've drawn little bubbles here. That's to represent the fact that we get oxygen gas produced at the positive electrodes. Is this oxidation or reduction? Well, the oxide ions have lost electrons, there they are there, so this is oxidation. So if we look at what happens at the cathode now, the negative electrode, so the aluminium ions are attracted to the negative electrode because of the opposite charges, so Al3+, and what they're going to do is these electrons that the oxide ions have lost are going to end up sitting on this negative electrode, and so an aluminium ion would gain 3 electrons and form an aluminium atom. And so what you would see is the molten aluminium would start to collect at the bottom here. So this is Al liquid, and it would run out of the tank. That's why I had that little gap there. One last bit of information to finish with, and it's what happens at the positive electrode. Remember, oxygen gas is produced here. The electrodes are made from carbon, and so the carbon of the electrode will react with the oxygen that's being formed there and form carbon dioxide gas. So eventually these electrodes are going to wear away and they're going to need to be replaced.